So this is the third video on my series, Motion with Vectors. So in example 3, we're told that an object moves with constant acceleration so that its velocity changes from 3i plus 8j meters per second to 8i minus 2j meters per second over a 5-second period. For part A, we've been asked to work out the acceleration of a particle, and then for B, we've been asked to use this acceleration to show that this is a position vector in terms of t. Okay, so the first thing we need to do to work out the acceleration is to use our Suvat formulae. We know displacement isn't asked for or given in the question. We know the initial velocity is given as 3.8. The final velocity after 5 seconds is given as 8 negative 2. The acceleration we don't know, but we've been asked to find. So this will be xy. We know acceleration is a vector, and t is 5 seconds. So we're going to use v will equal u plus at. So if we substitute in these values, we know v is 8 negative 2, and this will equal u 3.8 plus t times xy. This is the I component of the acceleration, and this is the j component. So now to solve x and y, we can move the 3.8 to the left-hand side, so we get 5 and negative 10, and this will equal 5x and 5y. So 5x must equal 5, so x will equal 1, and 5y will equal negative 10, so y will equal negative 2. So we know the acceleration will be I minus 2j meters per second squared, okay? And then for part B, given that the initial position vector of a particle is negative I plus 4j meters, shown that the position vector after t seconds can be written like this. So because we're looking for t seconds, we can't use this as our final velocity, because this is after 5 seconds. So if we know that the position will be the initial position plus vt, well, we don't have this final velocity, but we do know that the product of velocity and time is a measure of displacement. So we can write this as r will equal the initial position plus the change in displacement. Now we can use our Suvat formulae again. We know s is what we're trying to find. The initial still 3 and 8. The final velocity we don't know. The acceleration we've worked out as 1 and negative 2. And time we're writing in terms of t. So now we can use the formula s will equal ut plus a half at squared. If we substitute in our known values, so our displacement will be 3.8 times t plus 1/2 of the acceleration 1 negative 2 times t squared. So now we can substitute this expression for displacement back into here. So the position after t seconds will be the initial position we're given as negative 1 and 4 plus the displacement 3t plus 1/2 t squared, and for the j component 8t minus t squared. So now all we need to do is to add these two together. So the position vector after t seconds will have an I component of negative 1 plus 3t plus a half t squared, and a j component of 4 plus 8t minus t squared. We'll close this in brackets and we'll have meters. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from our website, mrmathematics.com. There's a link in the description below. Thanks again and take care.